Let's take a look at graphing linear equations in a rectangular coordinate system. We'll do a few examples of different types of problems. In this first problem, we're graphing with intercepts, which means we're going to plug in 0 for x and solve for the corresponding y. Then we'll plug in 0 for y and solve for the corresponding x. We'll plot those points on our graph, and I've just included a grid here that looks like graph paper with an x-axis running horizontally, a y-axis running vertically. The scale is 1 on both. So let's start by plugging in 0 for x. We'll have 3 times 0 plus y is equal to 0. We know 3 times 0 is 0, so we just get y is equal to 0. So our ordered pair, we plugged in 0 for x and we got 0 for y. So if we try to turn around and plug in 0 for y, we'll get 0 for x. There's only one intercept. This line passes through the origin. So we can go ahead and plot that point. We know that it passes through the origin, but we can't draw a line with just that one point. So we can't actually graph this with intercepts. We have to get another point. We can pick any x value and plug it in and solve for the corresponding y. So I'm going to pick 1 because that's easy. 3 times 1 plus y is equal to 0. So I get 3 plus y equals 0, and I subtract 3 from both sides, and I get y is equal to -3. So my ordered pair, we plugged in 1 and we got -3. We were plugging the value in for x and we got -3 for y. So now I have a second point. X is 1, y is -3, so on the x-axis I go over to the right to +1. From there I go down 3 units and I put a point. Now I use those 2 points to draw my line. And I put arrows on the ends to indicate that it continues infinitely in both directions, and that's my line. And with course compass, you would just put your point on the origin, you would put another point on your second one, and then use the line tool to draw the line. You need to know how to do it on both course compass and on paper, because for the test you'll do it online, for the final you'll take it in the testing center on paper. Alright, let's look at another one. Okay, this time we're graphing with the slope and the y-intercept. And this one's pretty simple because it's already in y equals mx plus b form. So if we think about what's our slope, we know that m is the coefficient of the x. So m represents slope. Our slope is -3. And if I want to use that as rise over run, I write that over 1. And I call it rise over run, so I don't forget which direction to go. My y-intercept, remember the form is y equals mx plus b. M is the slope, b is my y-intercept. So my y-intercept in this case is +2. I write that as an ordered pair, has an x-coordinate of 0, a y-coordinate of +2, because it's on the y-axis. Remember, our y-axis is vertical, so on the y-axis we go up to 2 and put a point. From there we use the slope to get another point. My rise is -3, so from this y-intercept I go down 3 units, 1, 2, 3. And then my run is +1, so I go right 1. And I put a point there. If I wanted to get another point, I could by going down 1, 2, 3 again, right 1, and get another point right there. And I put an arrow on each end to show that it continues infinitely in both directions, and that's my line. And my third point was a little messy, but you know you should make the point accurately where it belongs. Okay, on this one we went back to graphing with intercepts. So we're going to look for that x and y intercept again, we're going to say 2 times 0 minus 3y is equal to 12. Well, 2 times 0 is 0, so that leaves me negative 3y is equal to 12. I divide both sides by negative 3, and I get y is equal to negative 4. So my first ordered pair, my y-intercept, has an x-coordinate of 0, a y-coordinate of negative 4. To get the x-intercept, remember we plug in 0 for y. We can do that because we didn't get the origin when we plugged in 0 for x. So now we say, okay, 2x minus 3 times 0 is equal to 12. So 3 times 0 is just 0. That leaves me 2x is equal to 12. I divide both sides by 2, and I get x is equal to 6. Now remember, when you write this ordered pair, we plugged in 0 for y. We solved for x. So the x-coordinate is 6, the y-coordinate is 0. That's our x-intercept. If we plot these 2 points, the y-intercept is negative 4, so on the y-axis we go down to negative 4 and put a point. The x-intercept is positive 6, so on the x-axis we go over to positive 6 and put a point. Now we draw the line. We put an arrow on both ends to show that it continues infinitely in both directions, and that's our graph. Okay, on this last example we're graphing with slope and y-intercept again, but this time it's not quite so easy because it's not in y equals mx plus b form. This one's in standard form, and we need to solve for slope-intercept form before we try to graph. To do that, we're going to subtract 3x from both sides, and we're going to write that as 2y equals negative 3x plus 6, because we had a positive 6. We're putting the x first because we're trying to write it in mx plus b form. Now we're going to divide everything by 2, and remember you have to divide all the terms. So we get y is equal to negative 3/2, or 3 over 2, or my coefficient of my x, plus 6 divided by 2 is 3. So remember, y equals mx plus b. M is the slope, so my slope is negative 3 over 2, and that's rise over run. My y-intercept is positive 3, and that's an ordered pair with an x-coordinate of 0. That's a point on the y-axis. So we go to the y-axis first, and we start with the y-intercept. It's positive 3, so we go up to positive 3 and put a point. From there, we use the slope to get to another point. Our slope is negative 3 over 2. So if my rise is negative, I'm going down 3 units. 1, 2, 3. My run is positive, so I'm going right, and it's 2 units. 1, 2. And I put a point. If I wanted to get another point, I could go down 1, 2, 3 units, right 2, and get a third point. Now we draw the line. And that's our graph. So that's graphing with slope and y-intercept. First, you're solving for y to put it in y equals mx plus b form. That's called slope-intercept form. M is the coefficient of the x, and that always represents your slope. B is the y-intercept, and that's always the point that you start with on the y-axis.